All right, in this particular assignment, what we're looking at is relating ratios in right triangles. So we have a triangle here, A, B, C, that has given us some information. We have 55 degrees here. We have 90 degrees here. This will be 35, because 35 degrees and 55 degrees add up to 90. These angles right here will always be complementary. All right, so one thing you need to understand when you're doing these problems is if I have a 55 degree angle, these are going to always add up to 90 degrees. So in your journal, you might want to write down the sine of theta will always equal the cosine of 90 minus theta, or the cosine of theta equals the sine of 90 minus theta. These will always be complementary. Now theta is just an angle, like the measure of an angle. So there's so many ways right now. There's a lot of different ways that I could solve for the distance known as BC. Okay? So the first way I'm going to do it is I'm just going to use the 55 degrees and set up two different ways to solve for x. Because this particular question says, which expression represents the length of side BC? So I'm going to call this x. So I'm going to start with 55, then I'm going to change it, and I'm going to go right here. I'm going to go from 35. So one way I'm going to solve for it is this is my adjacent side, and this is my hypotenuse from this perspective. So I could say adjacent over hypotenuse is cosine, so I could say it's the cosine of 55 degrees equals x over 6. So that's one way. When I cross multiply, I get x equals 6 times the cosine of 55. So that would be one example. Another way you could do it is you could do the tangent of 55 degrees, because this is my opposite side in relationship to my adjacent side. So I could do the tangent of 55 equals 4.9 over x. But when I cross multiply, I get x times the tangent of 55 degrees equals 4.9. But I'll have to divide both sides by the tangent of 55 degrees. So another answer would be x equals the tangent, 4.9. Divided by the tangent of 55 degrees. Now that's from this perspective right here. The other perspective that I'm going to use is I'm actually going to use going from the 35 degrees. So if I go from 35 degrees, now x is now my opposite side, and this is my adjacent side. But that 6 still represents my hypotenuse. So if I wanted to solve from the other angle, I could say opposite over hypotenuse. I could say the sine of 35 degrees equals x over 6. And when I cross multiply, I get x equals 6 times the sine of 35 degrees. And the other way I could do it is I could say the opposite over the adjacent side. Once again, I could say the tangent of 35 degrees equals my opposite side over my adjacent side. So this one would be x equals, cross multiply, 4.9 times the tangent of 35. So what I'm looking for is I'm looking for any of these answer choices in the Khan Academy. All right? So I'm going to go over here. I'm going to scroll down. Take a look. So I have 6 cosine 55. So there's 6 cosine 55. All right? And then the complementary one would be 6 sine 35. So there's my 6 sine 35. So you'll see that if one's 35, one would be 55. These will always be complementary. All right, so here we go. Looks like Ishmael tried to prove that the sine of theta equals the cosine of 90 minus theta. Well, that is true. this is definitely true, but his proof is not correct. So what we're going to try to figure out is where he went wrong. All right. So let's take a look. Where was his first mistake? All right. Let's take a look. Step number 1, angle B. Angle B is 90 minus theta. Well, that is true. Angle B is definitely 90 minus theta. So for example, if I said this was 30 degrees, this would be 60 degrees. Okay. Now he says the sine of theta is AB over BC. So the sine of theta is AB, that's the opposite side, over BC, which is the hypotenuse. So is the sine equal to the opposite over the hypotenuse? Yes. So the sine of theta, that's true. Okay. Now the cosine, it says, is 90 minus theta. Well, that's true. But it says it's AC over BC. Well, the cosine is actually, in this particular case, the cosine would be AB over BC. So the cosine of 90 minus theta would actually be, it's not AC, it would be AB over BC. So I am going to say this is where he went wrong in step number 3. Because remember, the cosine is supposed to be the adjacent over the hypotenuse, not the opposite over the hypotenuse. So I'm going to say step number 3. He used the wrong, where is it? He used the wrong sides in his ratio for the cosine of 90 minus. I'm going to say that is where he went wrong. Okay, so that's what you guys are going to be working on. You're basically looking at whether or not things are equivalent or not equivalent, or finding where they made a mistake. So the best way to do it is just to work through the problem and figure out if they did it correctly or did it incorrectly. The next thing we're talking about is some right triangle word problems. Okay, so they've given you some pictures here, and we're just going to read through them and answer the questions that they've given us. Howard is designing a chair swing. The swing ropes are 5 meters long, and in the full swing they tilt an angle of 29 degrees. Howard wants the chairs to be 2.75 meters above the ground. How tall should the pole of the swing ride be? Okay, that's easy. So all we got to do is literally find the length of this like long pole right there. What I want you to do is kind of cut this over right here. Make a little right triangle. All right, make a little right triangle right there. And we already know we have what, 2.75 right here. So whatever I find for like this side, whatever I find for this length from here to here, I'm just going to add a 2.75 to it. All right, and it says round it to the nearest hundredth, so we'll just do that. So right now, I don't know if you guys can see this, but we have a nice little right triangle right there. This is 29 degrees, so I'll put 29 degrees. There's my right angle. Here's a 5, and I'm looking for x. So if I draw my little arc and my arrow, this is my opposite side, this is my adjacent side, this is my hypotenuse. So I could literally, I'm going to use my adjacent side and my hypotenuse and use cosine. So I'm just going to write the cosine of 29 degrees equals my adjacent side, which is x, over my hypotenuse, which is 5. So when I cross multiply, I get x equals. Now if you're wondering, like, what the heck are you talking about cross multiplying? I cross multiply. X times 1 is x, and I'm left with 5 cosine 29. So I got to get that in my calculator. I can't do that in my head. Okay, so up to 5 cosine 29. I get that, 4.37. Okay, got it, 4.37. But what do I have to add to that? I got to add 2.75 to that. So I'm going to add 2.75. Not 5, 2.75. Looks like it's 7.12. 7.12. So it says, how tall should the pole of the swing ride be? I'm guessing this is the pole. All right, so put 7.12 meters. If I'm wrong, we'll find out why I'm wrong. But I think that's that. I think that's it. 7.12. Oh, I got it right. Sweet. All right, let's take a look at this one. Bugs Bunny. Oh, good old Bugs. Was 33 meters below the ground, digging his way towards Pismo Beach. I think he made a wrong turn in Albuquerque, though. Just kidding. When he realized he wanted to be above ground, he turned and dug through the dirt diagonally for 80 meters until he was above ground. What is the angle of elevation? Oh, angle of elevation. That's good. What is the angle of elevation? Well, the angle of elevation is this part right here. I'll kind of highlight it in orange. Right, I guess probably orange isn't the best color. Okay, how about green? There we go. This is the angle of elevation. By the way, if we call this the, right here, if I call that the angle of elevation, does anybody want to tell me what this angle is called right in there? Anybody remember that? Well, that's called the angle. Surprise, teenagers should know this. The angle of depression, because we have so much depression in our world. So this is called the angle of elevation. This is called the angle of depression. There we go. If you can't see that, I apologize, but that's the angle of depression. Don't be depressed. So we're trying to find the angle of elevation. I'll do a better arrow. By the way, the angle of elevation is always equivalent to the angle of depression, in case you're wondering. So right here, we're going to do the opposite side over the hypotenuse. So the sine of our, I'm just going to call it x. The sine of our angle is equal to the opposite side over the hypotenuse. So if I wanted to find out what this angle, I'll call it angle x right here is, that's going to be what's called the inverse of sine of 33 over 80. So right now, I'm going to go ahead and do the inverse of sine and do 33 over 80. Well, it has to be, oh, I had a question. Students like, why does it have to be the inverse? Well, here's the point of the inverse. I can't divide both sides by sine, but I can multiply both sides by what's known as its inverse. So these cancel out. Whatever I do to one side, I have to do to the other side. So that's what the inverse button is for, so that I can cancel out these and just get my angle. So that's why I had to put the inverse of sine. So 24 nearest 10, 24.4. That's what I'm going to type in here. 24.4. Ooh, Archimedes went to sleep beside a big rock. He wanted to get up at 8 a.m., but the alarm clock was yet to be invented, unfortunately. He decided to sleep in at a spot where the rock's shadow should end when it's 8 a.m., so as to be awakened by direct sunlight. Ooh, smart dude. Archimedes knew that at 8 a.m. the sunlight reaches the ground at an angle of 43 degrees. The rock beside, which is 7 meters tall. How far from the rock did Archimedes go to sleep? How far from the rock? Okay, now, interestingly enough, if this distance right here is 7, then what is this distance right here? That's got to be 7, right? That's got to be 7. So what I'm going to do is say, ha! I am going to put a 7 right there. And I don't know if you guys can see the right triangle that's kind of being built. Like there, see that right triangle right in? There's my right triangle. There's my 43 degrees. I'm going to put a little arrow going to the 7, which represents my opposite side. It says, how far away from the rock did he go to sleep? Well, that distance is from here to right there. So I'm going to call that side X. All right, so I have my opposite side, and it looks like I'm looking for my adjacent side, because I'm definitely not looking for my hypotenuse. So opposite and adjacent, that's tangent. So I'm going to write the tangent of 43 degrees equals my opposite side over my adjacent side. So when I cross multiply, I get x times the tangent of 43 degrees equals 7 when I cross multiply. And then I get to divide both sides by the tangent of 43 degrees. And my handwriting's looking a lot better than it did just a few minutes ago. So I'm going to do 7 divided by the tangent of 43. Probably because it's Friday. My handwriting gets better closer and closer to the end of the day. All right, 7.51, 7.51, nearest hundredth, so I got to put 7.51. Man, if I didn't round it, I'd be marked wrong. So you see how right here? Oh, hold on. Right here, I got to round to 7.51. Okay. So, I'll type it in, 7.51. Nailed it. That's all you got to do. All right. So just read through it, just figure out what you're looking for, and solve it, and you'll be good to go. Have a good day.